Hello guys, this is section 7.3 Big Ideas Geometry, and we want to prove that a quadrilateral is a parallelogram today. So just a reminder of some things about parallelograms. So we know that a parallelogram is any quadrilateral where the opposite sides are parallel. Now, because of this, we get that these sides, opposite sides are equal, opposite angles are equal, and our diagonals bisect each other. So, let's look at that and use kind of the things we know from last video to help us solve some new things. So, two ways to prove it. You prove that the opposite sides are equal, or you can prove that the opposite angles are equal. But we already know that parallelograms are like that because we learned that last video. So, we can prove that the opposite angles are congruent, or we can prove that the opposite sides are congruent. There's our two ways. So, here we go. So they have this picture here and they want to say, is this a parallelogram? Well, of course it is, because the opposite sides are equal. So yes, this is a parallelogram because our opposite sides are congruent and equal. That's kind of all we're doing today. We're saying, okay, how do you know this is a parallelogram? Well, I know it's a parallelogram because the opposite sides are congruent. Let's keep going. So it says you have some quadrilateral, W, X, Y, Z, where W is 42, X is 138, Y is 42, and Z is, we don't know. But we do know all of these are interior angles. And we know that a quadrilateral's interior angles always add to 360. So 42 plus 138 plus 42 plus X should equal 360. Combine your like terms here, you get 222 plus X equals 360. So minus 222, and we're going to get that X is 138. And they want to know, is this a parallelogram? Well, of course it is, because these angles are opposite and congruent, and these angles are opposite and congruent. So yes, it's a parallelogram, because opposite angles are congruent. There we go. So again, it's kind of building off what we already know to help us find the new stuff. All right, so it says find the values of X and Y to make this a parallelogram. Well, if it's a parallelogram, these opposite sides should be equal. So X plus 9 should equal 2X minus 1. Let's solve. Add 1, X plus 10 equals 2X, minus X, 10 equals X. Great. So X has to be 10. But also, since it's a parallelogram, these sides should be equal. So we should get Y equals X plus 7. Well, if X is 10, this is really just Y equals 10 plus 7, which is 17. And now, since both of our opposite sides are congruent, this is a parallelogram. Now, the last two ways to prove it are to prove an opposite side is parallel and congruent, or that your diagonals bisect each other. So again, we're using those same properties that we already knew to solve. So here we go. I've got these diagonals. Now, for this to be a parallelogram, this half has to equal this half. So I've got to figure out an x that will make this true. All right, so we've got to go ahead and move our variables. We've got -8 equals -2x. So then we divide by -2, and x equals 4. And there we go. We're done. Both of our diagonals are congruent, so that means they bisect each other. And since they bisect each other, this is a parallelogram. All right, and the last thing we've got to look at is this one. Well, if this is a parallelogram, then these sides are equal. So 3x minus 32 equals 2x. Move your variables. Divide by -1. But since it's a parallelogram, this also has to be true. Y plus 87 has to equal 4y. Move your variables. Divide by 3. And there we go. We've solved for x, and we've solved for y. We've made the opposite angles congruent, which makes this a parallelogram. Now, kind of the last thing, just to get a little practice, we look and we see, why are these parallelograms? Well, this one has an opposite side that's congruent, and these circles tell us it's parallel, so that's why. Here, opposite sides are congruent. And the last one, opposite angles are congruent. So, that's 7.3. That's the properties and proving that things are parallelograms. Make sure you do the homework, and I'll see you next time.